Projectile down the inclined plane means it's like we are throwing something from the top of a mountain and we are modeling that mountain like a inclined plane. So I'm removing the mic. So maybe audio is better now or it was better earlier. If better earlier, you tell me. I will use the not mic, it's earphone.
Both are weird, sir.
Both are weird. Weird, maybe my voice weird, man. Then what to do?
No, so this mic is too bright. That mic was too warm
Okay,
and
just a moment, I'll
muted.
connect
This
the
one
mic.
is too. I think the previous
Just
one
a minute.
was kind
Just
of
a
better,
minute,
but it
I'm
was
hearing
too
you.
closed and.
Okay, now it is better.
No
Now it is
difference.
no difference.
Ah,
Okay,
yes,
no.
sir. Yes, sir. Now it's better. Now it's better.
Yeah, okay. So suppose if I am throwing a projectile from the top of an inclined plane and the angle of the inclined plane, we are calling it as alpha. See, from wherever we throw it, there we are going to draw a horizontal. So the dotted line is the horizontal there. And we are throwing it with speed u and at an angle theta from the horizontal. So see, still the angle that we are measuring is from horizontal only. Now, since direction of interest is one is inclined plane, so what we will do, we will consider down the inclined plane as our positive x direction. Perpendicular to the inclined plane like that is our positive y direction. So this is our plus x direction and that is our plus y direction. So the initial velocity u will have a component along y and that is going to be how much? Since you see this angle is alpha, so it's going to make this angle also alpha. So this will be also alpha. So component of u will be one down the inclined plane, one perpendicular to the inclined plane, correct? So the component along plus y direction is u sine theta plus alpha. Component down the inclined plane is u cos theta plus alpha. Now the acceleration that is acting is still in the same direction, no? So the g is the net acceleration which is acting down. But since I have taken new directions as our x and y, so I have to find what all acceleration we have in our new x and y direction. And for that, we will be finding the component of the net acceleration in those directions. So effect of the g is going to be felt along x and along y. So what is the effect that g will have along our new y and new x direction? That will be given by the component that g is having along those directions. So you can totally find this angle, it is going to be alpha. Net acceleration is g down like that. So the component of net acceleration, so suppose if I tell you to travel in this direction, which is the direction of g, or you have undergone some displacement in this direction. So to find what is the effect of that displacement along y, what we will do? You will be finding the component of that vector along y. So if I find the component of the g, one that comes in direction perpendicular to the inclined plane is g cos alpha. And that is in the direction which is opposite to plus y. The component of the g along the inclined plane, that is g sine alpha. So since upward direction is our since g cos alpha is acting along minus y and g sine alpha is acting along plus x. No? So we'll be doing the same old thing. We will write the x things and y things separately. And I must decide a point where I will be keeping our origin. So maybe we are going to keep the point of projection as our origin. Our projectile is going to take this curved path and will hit the inclined plane maybe here. So wherever it's going to hit the inclined plane, if I ask you, what is the y coordinate of that point will be 0. And whatever distance we are traveling along the inclined plane, no, that is the one which we are calling it as range. This this total this pink length is our range. And for the range we use the symbol r. So you tell me the coordinate x coordinate here will be r, no? So write down the x things, what it is. Ux is going to be equal to u cos theta plus alpha. Ax is equal to g plus g sine alpha. That is clear. And we must write what is the initial x position is. Never forget about that also. Initial x is 0. So this is the things that are for x direction. So for y direction, what is the initial velocity we have along y? Plus u sine theta plus alpha. The acceleration along y is minus g cos alpha. And the initial y is 0. So at t equals to 0, we are projecting it from here. And suppose at time t, it's going to reach the point whose coordinate may be, I call it as x comma y. No? So to find out the things like time of flight and range, what we do is kind of similar. So and also one more thing here, the maximum height is going to be this. No? So when I say maximum height, here I mean the height from the inclined plane surface. Okay? So check out the y things, because to find time of flight, we must be looking for the y things only. Because what will be thing that will be guaranteeing that this object has hit the inclined plane. So whenever the y coordinate here becomes 0 again, then it is sure that it is on the inclined plane again. No? So to find time of flight, what is the thing we will do? Same thing. That determine the displacement along y when it is going to hit the. But before that, if I ask you, at time t equals to t plus one, at time t equals to t, how much displacement it has undergone along y, that's going to be, that will be change in the y position. So that will be the final y, that is the y at time t, which is y only, and initial y is 0. So displacement along y is y only, no? So if I write the equation of the y, that we can write totally, as you can see, the acceleration that we have got along y is constant, no? So displacement along y will be uyt plus half of ay into t square. Displacement along y is y only. Uy is u sine theta plus alpha into t minus of half g cos alpha into t square. So I hope you can see that thing I wrote very small. So when the inclined plane is hit, or when it hits the inclined plane, how much is the displacement along y will be? 0. So same algorithm, is it not sort of? Displacement along y will be 0. And what is the displacement along y is? That is y only, so y should be 0. So in this equation, we are going to put y as 0, and that is going to give us two roots, giving us or telling us the time when y becomes 0. So u sine theta plus alpha into t minus of half g cos alpha into t square. If you solve for the roots, you get one root t equals to 0, and the another root that will be t equals 2u sine theta minus alpha by g cos alpha. Sorry, theta plus alpha by g cos alpha. Then it is totally fine because at t equals to 0, we know y is 0. That is like obvious kind of thing, but even obvious answers will be given by the mass. And again, when y 0, that is the time which is our time of flight. I hope it is clear now.
Yes, sir. But actually, phase three we were taught differently. Like here, you have taken alpha plus theta as the angle, but the whole angle was like we used the whole angle as theta.
Yeah,
Is the
whichever.
trans? Okay.
But this way, formulas are given in the book, our module, no? So that's why I'm doing
Okay,
like
sir.
that, because in case if you read from module, you should not be getting confused. That's why I'm going the way formulas are in our module. Because if you
Okay,
revise,
sir.
it will feel familiar. That's why. Okay, I can take a
Okay,
new
sir.
page now.
Yes, sir.
Okay, then. So up the inclined plane also, I have a recorded session named as the outclass. I will share it with you. You can watch that thing also. Okay, I'll take a new page
Okay,
now.
sir.
So to
Yes.
find range, what range is total displacement along x? So you check out first thing, the time of flight, what it came, is something kind of similar looking formula, 2u sine theta plus alpha by g cos alpha. So u sine theta plus alpha is initial speed along y direction, no? U stands for initial. And what is g cos alpha is? That is the magnitude of the acceleration along y direction. The range is total displacement along x in the time, which is time of flight. And that is going to be uxt. Just the thing here is ax not 0, half of ax into t square. So plug the value of the ux, that will be u cos theta plus alpha. Time of flight is 2u sine theta plus alpha by g cos alpha. Ax is g sine alpha, so half g sine alpha into t square, which will be 4u square sine square theta plus alpha by g square cos square alpha. Upon simplification, it is going to become 2u square cos theta plus alpha into sine theta plus alpha by g cos alpha plus 2u square sine square theta plus alpha into sine alpha by g cos square alpha. So we will take something as common just for simplification. So see, what I'm going to do next is I'm going to take common 2u square sine theta plus alpha divided by g cos square alpha. You check correct or not correct. So the first term will become cos theta plus alpha. So since I have taken common cos square alpha, no? So I will keep one cos alpha in the numerator plus sine theta plus alpha into sine alpha. And we totally see that thing fitting in a formula of cos A cos B plus sine A sine B. That is the formula of cos A minus B, no? So if I consider this angle as A, this angle as B, so it is going to be cos A minus B. So that is going to give us, this is going to be cos theta plus alpha minus alpha. That is cos theta, no?
Yes, sir.
So this is going to become 2u square sine theta plus alpha into cos theta by g cos square alpha. So that is what will be the range, or that is one of the formula of the range, but we write it in another variation also, so that I will tell you in the next page. So this one clear, no? We'll take a new page.
Yes, sir.
So range we got it as 2u square sine theta plus alpha into cos theta by g cos square alpha. So it's like trigonometry, man. So you know 2 sine A cos B is equal to sine A plus B plus sine A minus B. If you don't know, then you know it now. So I will consider writing theta plus alpha as A and this one as B. So what it is going to become? Sine theta plus alpha minus theta plus theta, so 2 theta plus alpha. Sine theta plus alpha minus theta, that will be plus sine theta. So another way to write this thing will be, so I have written 2 sine theta plus alpha into cos theta like that. So range becomes u square by g cos square alpha into sine 2 theta plus alpha plus sine theta. The reason we write him down like this way, I want to eliminate the term, sorry, what I done here? 2 theta plus alpha minus theta will be sine alpha, no? The reason we have written him like this because I want to eliminate, or I want to have theta to be appearing in one of the term only. In this formula, theta comes in both the terms. I mean, so analyzing things could be difficult. So if I consider, if I ask you that, tell me if u fixed, speed not changing, speed not changing, g not changing, alpha not changing, only thing changes is theta. So the only term that changes is this term, sine 2 theta plus alpha. And the more this term will be, the more will be the range or not? Because like directly, range is sort of like directly proportional to this term. It is appearing in the numerator. That's why. So when range will be maximum for what angle and what will be maximum range, we can find it out. So for R to be R max, I can say sine 2 theta plus alpha should become maximum, and maximum sine guy can become is to become 1. For what angle it will become 1? For 2 theta plus alpha must be equal to 90. So the maximum range occurs when theta is equal to pi by 4 minus alpha by 2. And what will be that maximum range? So we replace him with 1. That's all, no? So maximum range is u square by g cos square alpha into 1 plus sine alpha. And we can write cos square alpha as 1 minus sine square alpha. And that can be written as 1 minus sine alpha into 1 plus sine alpha. It's like using a square minus b square. So nicer way to write them down will be u square by g. So denominator cos square alpha will be written like this. And it will cancel it will cancel 1 plus sine alpha in the numerator. So maximum range is u square by g into 1 minus sine alpha. I hope this thing is clear. Clear, no?
Yes, sir.
Next thing is maximum height. It's kind of similar as well, the way it was from ground frame. At maximum height, you will know it will be having velocity along y0, because if it was having anything, he will keep traveling in that direction. And only velocity it will have will be along x. So velocity along x changes in this case every time, but the velocity along x is the only velocity he will have when it is here. So at this place, it is going to be moving parallel to the inclined plane, no? And whenever it is at that maximum height, which I am calling it as h, initial y0, so displacement along y direction will be h, no? So I will use vy square equals uy square plus twice of ay into sy. 0 equals u square sine square theta plus alpha minus 2g cos alpha into h. So maximum height is equal to u square sine square theta plus alpha by 2g cos alpha. So this formula is coming in familiar way. It is uy square by twice of magnitude of the acceleration along y. I hope this is clear now. Next person tell me the doubt, or you tell me the next doubt.
I don't
Samsung
have
guy.
doubts, sir.
Okay. Samsung guy, any doubt? Motorola guy, any doubt? Shivani, any doubt? If you missed some class and you need some backup sort of thing, you can ask even that. Doubt class is for such things only. So tell me your doubts, man. Shivani.
Projectile motion exercise 1, question number 9, sir.
Okay. Projectile motion. Projectile motion exercise 1, question number 9. No? Find the condition under which the projectile will hit the inclined plane perpendicular to the inclined plane. So whenever it's hitting inclined plane perpendicular to it, what angle it is going to make from the inclined plane? 90 degree. Correct. So we will use that fact to figure out the answer. This way is our positive x, this way I took positive y. Thrown with a speed u, what is the angle he has got from the inclined plane? That will be theta minus alpha. And the g components that are going to be same, just different is our x direction. Instead of down the inclined plane, it is up the inclined. So G sine alpha acting down the inclined plane, G cos alpha acting in this way. So whenever it's going to take some path which is like a path will hit it here, and when it is going to hit here, his entire velocity is in the direction which is perpendicular to the inclined plane. So what will be the velocity along x he will have? 0. Then only, no? The velocity along x is not 0, so it will end up making some angle with the inclined plane, which is not going to be 90. So velocity along x 0, but what velocity along x? The velocity along x when it will hit the inclined plane. But when it will hit the inclined plane? When time is equal to capital T. And what kind of motion it is having along x? Constant acceleration. So what I will use? Ux plus ax into t must be equal to 0. And what is our ux is? U cos theta minus alpha. In this case, ax will be minus g sine alpha. And time of flight we know 2u sine theta minus alpha by g cos alpha. And that should be equal to 0. So after this, you simplify it to get a matching option. That depends what kind of options are. Just I'll simplify it. You see, g gone. U I can cancel. I can throw it to that side. So it becomes cos theta. A little bit trigonometry will be of use. So maybe that's why you were unable to solve it. Cos theta minus alpha is equal to 2 sine theta minus alpha by sine alpha into cos alpha, correct? So if I leave it here, if you leave it here, you have done your part. Just it is checking, just I have to check whether you know some trigonometry or not. So if you leave it here, you should get full marks. But I have to match an option also. So what we get is, I can write this thing as 2 tan theta minus alpha is equal to, okay, I did a mistake here, no, see? I do so much mistakes, man. 2 sine theta minus alpha, sine alpha by cos alpha. That is what it is. So 2 sine tan theta minus alpha is equal to cos alpha by sine alpha. And now I will use that formula of tan A minus tan B, tan A minus B. That will be tan A minus tan B by 1 plus tan A tan B. So this formula you don't know, then you will not be able to solve. That's all. So we get 2 tan theta minus 2 tan alpha divided by 1 plus tan theta into tan alpha equals cot alpha. So 2 tan theta minus 2 tan alpha, throw the denominator of LHS to RHS, that will give you cot alpha plus tan theta, correct? So I'll take tan theta this side, it becomes, okay, this much only giving us the answer, no? I don't have to solve any further, only to do this much. We got one option matching in spite of this. So what we get, 2 tan theta minus alpha is equal to 2 there, no? Cot alpha. Or I can write him down like this also. 2 by cot alpha is equal to 1 by tan theta minus alpha. I have to match an option what to do. So cot theta minus alpha is equal to 2 tan alpha. So now option D matches. Clear?
Okay, sir.
Physics part was nothing, no?
No, sir.
Yeah,
Please
correct.
continue. Yes.
After that, you have to just simplify just to see one option matching. Tell me next out.
Same exercise 18th one, sir.
18th one. A ball is thrown from a point with a speed v0 at an angle theta. From the same point, a person starts running with constant speed v0 to catch the ball. Will be the person who is going to catch the ball or not? If yes, then at what angle it is thrown? So in the time in which the ball will reach the ground, in that much time that person has to reach the point where the ball falls on the ground. And some assumption we will do that height of that person is like 0. Otherwise they should have given us the height, no? So that person is like snake or something, like crawling on the ground. And that person runs with a speed v0 by 2. Ball is thrown with speed v0, but at some angle theta. So tell me, if both of them are starting from same time, so less confusion. And both of them must arrive here at the same time, which is going to be time taken by the projectile to reach here. So time of flight result we know, 2v0 sine theta by g it will be. So whatever the range the projectile has, same the man must travel in the same time, correct? So range of the projectile must be equal to v0. So with what speed the person runs? v0 by 2. For what time he runs? T. So what is the distance he will cover in time t? v0 by 2 into t. And what is the range of a projectile is? Velocity of the projectile along x into time of flight, because here I don't have any acceleration along x. So v0 by 2 into t. So t gone. So what we get? Vx, what Vx will be? v0 cos theta. So v0 cos theta is equal to v0 by 2. So what cos theta is equal to? 1 by 2. So we get a possible value of the theta for which it is possible for the range to be equal to same distance the man covers in the same time. So if I get suppose cos theta as 3 by 2, then not possible, no? So I should be getting some possible value of the theta, then only I can say this thing is possible. So yes, it is possible for the man to catch the ball, but the angle of projection should be 30 degrees. So yes, 30. Clear, no? Easy question only or not?
Yes, sir.
Next, so tell me. Next, so tell me, or else I will ask you to solve a question. So phase 3 students, you have done this question in class or not? Exercise 3. Where is 3, man? Yeah. Exercise 3, question number 7. In phase 1, we have done that thing. Phase 3 students may not have done that thing, no? Exercise 3, question number 7. Anyone having doubt also, tell me.
We didn't do that question, sir.
Yeah, so then maybe you try for a minute, because I want to fetch coffee. In meantime, you try this question, then I will solve this question, and I will give you another question looking like this, and we will solve a JEE advanced question same like this. So this question was there in our module from at least 10 years, 7, 8 years. I am in LN, like maybe more than 8. But this question came after that in like recent years. Sometimes simple things can come in JEE advanced also. which is already there in the module also. And every year, one of my class question in 2 years, at least one thing might come in JEE Advance. Every year I tell this question, this kind of thing they will ask, and it comes, man. Till now, every year it has happened. But one question only. One question is not like big deal, but still. To try this thing in meantime, just I'll bring coffee. Okay. Okay, I'm back. So I hope you've given it right. So see, the particle is moving along this parabolic path, and that is given y equals x square. So totally you can guess now in which plane the motion of the particle is happening, xy plane. And what I have to find acceleration. But how to find acceleration, man? So the
Then check.
only thing we know till now is to deal every vector in terms of its components. Correct. So the particle has got its motion along x. So whenever we have to find an unknown vector, so what we do, always we do this thing. We assume an unknown vector. I've told this thing before in the class also. Suppose if in junior math class, if you have to find something, you will assume that thing as x. And according to the story given in the question, you will make equation containing x. And then you solve for x. So whatever is unknown, you assume it as something x. So here I have a vector unknown. So I have to assume it. But the problem is how to assume a vector. Because assuming a vector takes assuming two things, magnitude and direction. So if I'll say suppose magnitude x, but how you will assume direction when brain will not work, no? Like how to assume direction, correct? So, but the nice thing is, if I know a vector in terms of its components, I know everything. It's like full story of the vector. I know what is the length he is having, what direction or what angle it is making from x, y, z. Everything we can find. That's why is it not good thing to do is to assume an unknown vector in terms of its components. So once you clearly know what really I have to find, then only you can find that thing, no? If problem itself is not clear, how you will be finding the solution? So the motion of this particle, so to assume an unknown vector in terms of its components, I must know or I must guess what all components the given vector can have. So motion of this particle is in what plane? XY plane. So he is living in XY plane, doing everything in XY plane. So what all velocities he can have along X and Y only. So what all acceleration it can have along X and Y only, because velocity along Z is always zero. So what will be the acceleration along Z? Always zero. So motion of the particle is in XY plane. So since motion is in XY plane, so the acceleration can have two components. One can be X, one can be Y. So we are assuming him like this. Now the nice thing is, one thing they've given, it is moving along this curved path, but with what speed? The speed is always same, but since his direction always changes, due to which it is it must be undergoing or it must be having acceleration, no? And they've given a curve which is like simplest, which is some famous curve, parabola y equals ex squared. Sorry, I told something wrong. How it is moving such that the x component of the velocity remains constant. So at any moment, the net velocity will be along the tangent to the path. So that velocity will have a component along x, will be having some component along y. Now, the moment I write ax, how to find ax, man? By finding out the rate of change of x component of the velocity. How to find ay? By finding the rate of change of y component of the velocity, correct? So Vx, they are telling us it is constant, and that is c, given like c. So what is the rate of change of Vx is going to be 0. So what is the acceleration along axis? 0, correct? So we found one component, only one component remains to be found. So what to do after this? So the equation of the curve they have given us, not just like it will look nice or give parabola, there might be some use, no? If I ask you how to find Vx, any idea? By finding the rate of change of x position. Because Here Vx given, so no problem. I found his rate of change. But Vy not given, no? So how to find Vy? By finding out the rate of change of y position, no? Then how to find the rate of change of y position? Any idea? For that, I will use the equation of the curve. Y is equal to ax square. So dy by dt is the velocity along y, but what it is equal to? It is equal to dy by dt of ax square, and in there x is changing with time obviously, but what about a? A is a constant, so that constant a I will take it outside. So that will be a into differentiation of x square with respect to t. Now that reason chain rule was told, no, was not told for the purpose that you will be using it to do differentiation. Was told for such kind of purpose like this. Differentiation of x square with respect to t I have to find. I don't know how to find, but what I know to find is differentiation of x square with respect to x. So for the sake of we can be able to do the differentiation, I multiply it with dx and dx. Totally legal thing to do, correct? And then I exchange their denominators. So we get differentiation of x square with respect to x. I'm exchanging their denominators. So I'm using a color coding here into dx I hope you got the point here, no? What happened? This blue one here, this black one here, clear? After this, it is solvable, no? So it is going to be differentiation of x square with respect to x will be how much? 2x, and differentiation of x with respect to time is what? Velocity along x. So what we get? Velocity along y is equal to 2ax into bx. So do the differentiation of vy again. Do the differentiation of vy so that we can find ay. All of you do it. Murari, do it now.
Yes, sir.
Maybe do it in your head. 2a is constant will be taken common. Then I have to differentiate the product of x and vx. X in itself is a function of time. Vx is also a function of time. Constant function of time, but function of time or not. So you will be using product rule. So apply product rule. Then plug the value of the rate of change of Vx, which is 0. And then see what answer comes. And that will tell you Ay. Ax we know already. Ay we have known. So we have known the total acceleration. Okay, so I'll do that step also. So Ay will be equal to rate of change of Vy, and that will be 2 before itself I wrote it outside into x into Vx, the differentiation of that. And for this we will be using product rule. So 2a in product rule we keep one thing as it is and we differentiate the another one. Suppose if I keep Vx as it is, I differentiate x. Then reverse. We keep x as it is and we differentiate Vx. So what is the acceleration along y became 2a. So dx by dt is velocity along x, so vx square. And differentiation of vx is ax, so x into ax. So that is really our ay, but it is told that ax is 0, so I will replace him with 0. So what ay became? Ay is equal to 2a into vx square. And what is vxc? So 2a into c square. So that is the acceleration we will be having along y, and that is the total acceleration or not. Clear, no?
Yes, sir.
Okay, then I'll take a new page and I'll give another question. Try that question. A particle is moving along a parabolic path y equals 2x square with constant speed, which is 1 meters per second. I'll write down. A particle moves along the path y equals x square with constant speed of 2 meters per second, suppose. Find the net acceleration when it is at origin. So I don't have to find it at any other place. I have to find it out when it is at origin. There was in general, no? They told us find acceleration of the particle, means have to find acceleration as a function of time or at any general point. And we found out at any general point, the acceleration along y is 2ac square, and that is what? Constant, no? Before you do that question, tell me one thing. In projectile motion, what is the acceleration along x is? 0, correct? And what is the acceleration along y is? Negative, correct? But constant, no? What was the path we were having? Parabola, correct? And what kind of parabola it was? Concave down, correct? So check out the similarity here. What is the acceleration that we have along x? 0. What is the acceleration along y is? Constant but positive. What kind of path I have? Parabola, but differently looking parabola because different but constant acceleration we have along y. So clear, no? So try this question. Find the net acceleration when it is at origin. So again, you think like that I have to find acceleration. It will be having two components basically, axi cap and ayj cap. Maybe I'll draw the diagram of figure also. Suppose it is moving along this curved path y equals x square in this manner. So whenever it is at origin, its motion will be along the tangent to the parabola, and that will be along x-axis, correct? So his entire velocity lies along x direction. So, and what is the velocity he has? Is of magnitude 2, but in what direction? X direction, no? So tell me, if I ask you, what is the velocity it is having at the moment when at origin? So at origin, the only component he has is what? X component, no? So I'll write down as Vx E cap, correct? So tell me, if I ask you, what is the speed of the particle when it is at origin? What is the answer you will give? Whatever is the magnitude of his x component, that is the speed he has. So the speed of this particle is going to be same as Vx, correct or not correct? Correct, no? Tell me,
Yes, sir.
correct? So
Yes,
if
sir.
and what is given that it is moving with constant speed. It means his rate of change of speed must be 0 everywhere, even at origin. And rate of change of speed 0 will tell us that rate of change of the x component must be 0. I don't know what it will be at other place, but at origin, this is true or not. So at origin, the rate of change of his x component must be 0, because if not 0, then speed changing. Speed cannot change. Its rate of change of speed must be 0. So for rate of change of speed to be 0, rate of change of Vx should be also 0, because speed when it is at origin is same as Vx. It means at origin, whenever it is going to be there, the acceleration that he has along x 0. The next part of this question is exactly same as the earlier part. There we had different reason to say ax0 because it was given. Here we are finding that thing 0 by some logical reasoning. So after that we will use that curve that we have y equals x square. So dy by dt I have to find, then only I can find vy. That will be differentiation of x square with respect to t. And this is Vy, but to find it out, I have to find differentiation of x square. For that, I will multiply him with dx and dx. And after that, we get Vy equals differentiation of x square with respect to x into differentiation of x with respect to t. So Vy becomes 2x into Vx. So we will differentiate him to find Ay. So dvy by dt will be, so directly I will apply product rule. That will be Vx into dx by dt plus x into dvx by dt. But when at origin dvx by dt, it's going to be 0. So this one became 0. So what it is going to become 2vx into vx. dvx by dt is vx, so it is going to be 2vx squared. So Ay at origin is 2Vx square. And what is Vx? The speed 2. So what Ay will be? 2 into 2 square. That is going to be 8. So the acceleration of the particle when it is at origin is going to be 8 j cap. Clear, no? Yeah, correct. You got correct answer.
Yes, sir.
Okay. So tell me, any more doubts anyone is having? Any doubt in the laws of motion part?
No, sir.
Okay, nice. Not all then. So laws of motion is like old module, man. Yeah, but questions are kind of same only. Exercise 1, I don't know what question it will be in your module, but it might be there also. So try this question, everyone. Uniform rope of mass 2 kg can tolerate, spelling wrong here, a maximum tension of 80 Newton at any point. Find the maximum value of the F which can be applied on 2 kg of the block so that the string or that rope should not break. So tell me, if at all we are pulling them like that, where the tension will be more? So this is a person whose head is 2 kg. legs are like 3 kg, where in the remaining body, where he will be feeling more pain, at the neck or at the maybe thighs and all? Neck only, no? And so do one thing, you decide at which point tension will be maximum. So we have done this question in the class, that hanging rope one. So tension was maximum at the top or not? Correct. So this rope is of mass m, and this rope is stationary. How come this rope is not falling down, even though earth pulling him down? There must be some force acted upon him. Who will be applying it? The ceiling. So tension at the topmost point will be acting upwards on the rope. And what really the job tension does is to balance the full weight of the rope. So tension at the top is going to be equal to mg. Now if I ask you what is the tension we are going to have at the middle of the rope, I don't know. Maybe I call it as T. And if I draw the diagram of this below part, how tension will be drawn on him upward, and what is the mass of half the rope will be. This length is L by 2, half length, and rope is uniform rope. So it's going to be having half mass mg by 2. So tension in the middle is going to be how much? Mg by 2, no? So tension at the middle is mg by 2, because what really the job tension is doing is balancing half the weight of the rope. Tension at the top, what it is doing, balancing the full weight of the rope. So as we move more upwards, the tension becomes more and more or not. So here this setup is not remaining at rest. Instead, it is being pulled upward, man. Even in that situation, tension will be maximum where? At the topmost point. And if the rope breaks, then it must be breaking at the topmost point first or not, because there it is handling maximum tension, no? So if tension at the topmost point is less than 80, then it is a guarantee that tension at every other point will be less than 80. Correct, no? So I should find out under what circumstance the tension at the top will become more than or equal to 80, or we will find under what circumstance the tension will be equal to 80. So in that case, whatever the force we apply, that is the maximum force we can apply, because the moment we apply any more, the tension will become there more than 80 and it will break. Correct? I hope this logic, these things are clear, whatever I have told now. Now you draw the FBD. So consider tension here is T. So you disconnect the rope from here and you draw the free body diagram of the 2 kg block and the remaining part. Till I am drawing the diagram here, you try to draw it in your head at least. So these things are easy only, no man. Tension rope, how it can be difficult, no? So the tension at this point where 2 kg block is connected with the rope. I'm drawing it. Tell me I'm correct or not correct. It's going to be acting like that, no? Even though you don't know how tension force behaves, you don't have to know everything every time. Just you think of this 2 kg and 3 kg as one system. How come these two are going up? Why not they are falling down? Because there must be some force pulling them up. What force it can be? The tension there. So tension will be acting like this and like that, no? And what all things other than tension will act on each of them, and that will be the pull of the gravity. Just a second. What else will act? mg. So its mass is 2. So 2g will act down. What else will act? The mass of this much rope is 2 kg and this 3 kg. So total 5g will act down. And what really they are doing? Both are going with same acceleration, E and A. He is going up with A and he is also going up with A, correct? So write the force equation for first one. That net force in the upward direction will be Ma. So what is the force vector Fe will write down as plus F? Because 1D motion, things going up, maybe I will take upward as positive. And then I have to find the vector sum of every force. So upward vectors taken positive, downward taken negative. So I hope this is like clear to everyone. F minus T minus 2G is equal to 2A. Its mass is 2 kg. For this one, I have T acting upward and 5G acting down. And all together, they are going with an acceleration A. What would be the mass in total they have? 5 kg, no? So we have T minus 5G is equal to 5A. So what we will do next is we will solve these two equations to find T and A. So this is totally, you can see if I add this two, TT will get cancelled. And what we get, F minus 7G is equal to 7A. So A will be equal to F minus 7G by 7. And after that, we are going to use this value of the A in any of this equation, maybe in 1 or 2. So maybe I will use it in equation number 2. So we get T minus 5G is equal to 5 by 7 into F minus 7G. So what is the maximum tension it can handle is 80 Newton. So if T is going to be 80, what is the force F that is going to act? That is what we have to solve for. So I'll write T as 80. Why to complicate things? I will plug the values here only. G not given, maybe I'll take it as 10. But in actual exam, you should take it as 9.8. 5 by 7 into F minus 70. So after this, I think you can solve. 80 minus 50 will be 30. So 30 into 7 by 5 is equal to F minus 70. So F equals 70 plus 42, and that will be 112 Newton. Clear, no? Clear to everyone, no?
Yes, sir.
Okay, then any more doubts? If no doubts, we'll end the class then.
No doubts, sir.
Okay, then bye everyone.
Bye, sir. Thank you, sir.
Okay then, any doubt? Samsung, you'll end the class then.
Okay, sir.
Okay. Bye-bye.